Satellite of mass m is equals to 100 kg orbiting at a radius of 1.5 RE. RE is the radius of the Earth. Energy required to reach to the orbit of radius 3 RE. So this is the Earth. Say this is radius RE. So this is 1.5 RE and this is 3 RE. So we have to take the satellite from 1.5 RE to 3 RE. Means from here I have made it to jump to 3 RE and it is also orbiting here. How we write the equation? We simply write conservation of energy form like energy in 1.5 RE distance. Sorry, energy at. This will be half mp orbital square plus minus of gmm by r, where r is 1.5 RE. We'll write it later. And energy at 3 RE distance. This is 1 half mv orbital square at 3 RE distance minus gmm by r. Now it is obviously at this point having lesser energy, or so we'll add some energy to it so that it reaches here. So I just need to add a term, say E, and this is what they are asking for. What is the energy added so that it goes from this place to this place? So that is what we can write. Before I write it here, to make the calculation easy, we should know what is orbital velocity, and that is r square g upon r. If you try to find it, you will get it. For any distance, in terms of radius of the Earth, the orbital velocity is r square g by r. So if I want to find for the 1.5 r, I can already write it as r square g 1.5 r. So you can write 2 by 3 gr. That is for 1.5 RE distance. And if I want to find out for 3 RE distance, the orbital velocity will be r square g by 3r, which is g r by 3. Okay, so it is 2gr by 3 and gr by 3. That way I'll replace these values. Apart from that, this also can be written in terms of g, which I'll write it here only while writing the equation. So half m 2gr by 3 minus. So now what I'll do, I'll multiply by r square. Okay, and here multiply by r square, divide by r square. So this will become g. So g m, and I multiply by r square. That's why I've got r square in the denominator and could write this as chota g. So this will become r square, and now I'll write small r as 1.5 r. So this, if you can do it efficiently, not much calculation will be there. Otherwise, it can take a lot of time. So I'm explaining you. It is looking as if it is taking time, but if you are solving it without any disturbance or any need to explain anyone, you can simply do this. Rest half m, and at 3 RE, the V0 is gr by 3 minus g, and this again multiply by r square, divide by r square. This becomes small g. So I've written small g mr square and this small r is 3r. Now let's do some calculation. This is mgr divided by 3 minus, this is 2 by 3 mgr plus e is equals to, this is mgr by 6 minus mgr by 3. This e will be calculated as mgr by 6 minus mgr by 3. So I'll get minus mgr by 6 here. This is mgr by 3 minus 2 mgr by 3. So if I see it here, it will be minus mgr by 3. And if I bring it here, it will become mgr by 3. So energy will become mgr by 6. And that is energy is required. Now I put the value of mass as 100 kg, so I'll 100 gr by 6, that is 50 gr by 3, and that's the answer to the question.